Hello everyone, welcome to Pepcoding. In this video, we will look at the question, find the element that appears once in a sorted array. Okay, so let's say I have this question and I have this array. Right? It is sorted and we have to find one element which is distinct from all the other elements, right? Which is only present once in the array. Here my answer is going to be 4. How? Let's see. Uh, since I have pairs, right? Every element is present twice except that one element that we have to find. So here you can see we have 1 and 1, 2 and 2, 4 is single, 6 and 6, 8 and 8, and 9 and 9. Right? All these elements are in pairs, but this element only, this 4 only, is singular. Right? It's a single. So we need to find this 4. Okay. I hope the question is clear. Now we can solve this question pretty easily in O of n, right? We can solve this in linear time, but we have to solve this question in log of n. Okay, we have to solve this question in O of log n. Now, how are we going to solve this in O of log n? We'll apply binary search. So, before applying binary search, we have to focus on the main point here. Now, let's see the size of the array. Like, what is the size of my array? My size is 11, right? My length is 11 here. Now, you can see that for any array, if my length is odd, if my length is odd, then only I can have a condition like this. Then only I can say that I have a single element, right? If my length is odd. Why is that? Let's say my length was even. Length is even, and let's take the length as 6, right? Let's take an example of 6. Then my array is something like this. So 1, 1, 2, 2, 3, and 3. Okay. Now, if my array is of length 6, then only I can have pairs, right? Then if we don't have any pairs, if this is not true, right? If I have 6 length and we say that there are still elements present which are distinct, then you cannot have just one distinct element. Okay, so if you had something like this 1, 1, 2, 2, then 3 and 4, right? Then you would have at least two distinct present elements. So 1, 2, 2, but 3 and 4 are two elements which are single. They are not a single, there is not a single element which is single, right? There are two elements which are single. So this is not a valid question. But if you have all of the pairs, then there is no point or there is no space for a single element to be there, right? There is no space left for a single element. If the single element were to be present, then we wouldn't needed a separate space, right? So that space, if we need that space is going to make our length odd. But now it is even. If it is even, we cannot have we cannot have a condition like this. We cannot have a single element. So what we mean by this is that we can only have this condition. We can only say that that there is going to be a value present, right? There is going to be a single value present only when the length or the size of the array is odd. Okay, so this is a very important point. I'm emphasizing on this point a lot because this point we are going to apply our binary search on the basis of this point only. Okay, so we know that there needs to be odd size. Okay, so let's take this into consideration and let's apply binary search. We're just going to parse it once. Okay, so we have low here and we have a high here, right? My mid is going to be here at 5. This is my mid. Okay, so let's do this. Right? Okay, so I have my low here, my mid here, and my high. Now, for this part, right, I am checking what is going to be my value of the mid, right? If my value at mid is equal to or is not equal to my value on the left and it is not equal to the value on the right, then it would mean that it is the only value, right? It would mean that I am the only value. Why am I saying that? Okay, let's say I have 4 here, right? 4 is present here. 4 is valid because it is equal to 1 on the left, and but it is not equal to 1 on the right. It means that it exists as a pair, right? Here we have 6. 6 is also not the answer because it has a pair, right? It has a pair on either side of it. But if it was a single element, you can check it for 4, right? 4 is my answer. For 4, there is not a single value on the left, and it is not equal to the value on the right as well. It is only a singular element. If since the array is sorted, it would have paired up with someone, right? But there is no pair. So it means that it is the only value which is alone by itself. So first I will check that if I am equal to my left or equal to my right, right? Uh, if I'm not equal to my left and to my right, then I've found the element of the mid itself. Okay, so that is going to be my condition. Now we see our mid. Now mid is here, right? Now I can have three things, right? I can have three main things. What are the three main things? That the three things are: first, that array of mid, or let's write it like this: mid is not equal to left, right? The value on the left, let's call this as left, and it is not equal to value on the right, right? Or we can just say mid is not equal to mid minus 1, and mid is not equal to mid plus 1. If this is the case, right, if mid is not equal to mid minus 1 and mid is not equal to mid plus 1, then it would mean that this is the only value. So our first check is going to be this, right? This is going to be my first check. Let's remove this odd size. Okay, this is going to be my first check. Now, what are the other conditions that I can have? Else, right? Else if, what is going to be my other condition? We can see that 6 can be equal to left or it can be equal to right, right? These are my two other conditions. So else if, I can say that mid is equal to mid plus 1, right? The value at, I'm just saying it mid, but it is actually represent the value at the mid, right? Since mid is an index, right? So if mid is not equal to mid minus 1 and mid is not equal to mid plus 1, then we would have this condition. Else if mid is equal to mid plus 1, then we would have this condition. We can also have a condition where mid is equal to this value, right? So we have our three conditions, and we are going to work on the basis of these three conditions and the fact that we need odd size. Okay, so let's see. Let's say I'm at this point, right? I check and I see that I am equal to the value on the right. I am equal to the value on the right. Now, what does this mean? It means that since 6 and 6 are equal, and now I have this as my answer, right? This is my mid. So I can segregate this array like this, and I will check the sizes of the two parts. I have this part, I have this part, right? Now, if this size comes out to be odd, then it would mean that my answer is going to be on the right hand side, or my answer is going to be here. My answer will be somewhere here, because I know that the only way an element is going to be present would be that if it is present in the odd part, right? Because I know that we discussed this before, right? If we have 2, 2, 3, 4, and 4, then this case is only present when the size is odd. So we are going to use a binary search, and we are trying to decrease the size, right? applying the binary search and we are trying to decrease the size. So we can say, which one is my answer? Okay. So what we are doing is, we are at this point, we are at 6. 6 is, this is equal. Now we will check the size on the right hand side and the size on the left hand side. Okay, the size on the right hand side gives me 6 6 1 2 3 4 5 6. Okay, so the size on the right hand side is 6. The size on the left hand side is 5. Okay, so this definitely means that my answer is going to be on the left hand side, so I'll move to the left hand side. My low or my high is going to be mid minus 1. Okay, this is the case when it is 6 6 and 6. What we are trying to do is, let's say that I'm at this point, right? If I'm at this point and I see that I am equal to my right hand side, then I'll make a check. Then I'll make a check of my right count. Right? Let's say I call this part is my right count. This is the size of the right area, right? This is going to be the size of the right area. Then I will check that if this right area size is equal to, or modulo 2 equal to 0. If it is even, if this part is even, then my answer is not going to lie in this part, right? If this part is even, then my answer cannot lie in this part, since all of these values are going to be in pairs. So it would be better if I search here only, if I search in the left part. Okay, there is no need to search on the right hand side, because the answer here, or the size here, is even. Okay, so now we'll apply our binary search here, okay, or to this part. So let's take this high, let's move this here. Now my mid is going to be at 2, right? My mid is at 2. Now we will check again. See, my current value is equal to my right value. It is not equal to my left value. It is not equal to my right value. We made that check, then it failed because it is equal to the right value. Then when it is equal to the right value, we'll apply something, right? So it is equal, then we'll try to find the right count. Now right count comes out to be 3, right? 1 2 and 3. My right count is equal to 3. So it means that my value is going to be on the right hand side, right? If my right count is equals to 3, which is odd, right? Right count modulo 2 is equals to 0. This failed, right? This condition failed, right? If this would have succeeded, then we would have searched on the left hand part. But now this condition is true, so we are searching on the right hand part only. So my low is now going to shift to my right. And how my low is going to shift? Let's see. My low is going to go here. It is not going to go to mid plus 1. It is going to go here. And why is that? Why we are going to mid plus 2 actually? We are going to mid plus 2 because these two values are equal. And if I try to go here, if I put my low here instead of here, then this whole condition would be invalid, right? This whole thing we are doing would be invalid, because we would have an array of two distinct integers. The binary search we would be applying on the array would be of 2 and 4, and that would be invalid, right? So since these two are already in pair, right? These two are already in pair, so we just need to check on the right hand side. We need to skip these parts. My low was here, right? Or my low was here. So my low shift to mid plus 2. My low shift to mid plus 2, because I know that mid and mid plus 1 are equal. So I don't need to check for these values. Okay, I just need to check for mid plus 2. So I put my low here, I put my high here. Now my mid is also going to be here, right? My mid is also at 4. And since my mid is at 4, since my mid is here, right? Mid is pointing to 4, then it means I will apply this whole condition again. Now 4 is less than equals, now we will check for 4. 4 is not equal to its left, 4 is not equals to its right. It means 4 is a distinct value, and we found our answer. Okay, so now let's try to code this part. If you don't understand, it is completely fine. We will dry run the code and then you can completely understand it. Okay, so let's see. Full screen this. Okay. So first we need our array not length. Let's store it in n, and now we will check if my n is equals to 1. Okay, if my n is equals to 1, that means that there is only one element left. So I'll return that array of 0, or the only element which is present in my array. Right? So if I only have one element, then my answer is going to be that element only, right? Okay. So now my next thing is going to be if ARR of 0 is not equals to ARR of 1. Now what is this check? I'll return ARR of 0. What is this check? I'm trying to handle now the base cases, or I'm trying to handle the cases where my element is uh, on the starting of my array. So for example, my